Pharmacology Unit 1, Drug Dosage Calculation Formulas. Along with this PowerPoint, you should also have a sheet called Drug Dosage Calculation Cheat Sheet, where during the PowerPoint presentation, you're going to take the formulas that we talk about and you're going to transfer those formulas over to that cheat sheet, so that when you sit down to take your pre-exams, you're not flipping through this PowerPoint trying to find the formula that matches your scenario or your problem, but you can be looking at your cheat sheet, identifying that formula that goes to your problem to help you apply these concepts a little bit faster. Your pre-exam is going to be 50 problems, and some problems are going to have several different concepts that you have to apply to one problem. So there is a time limit of 90 minutes that you need to accomplish 50 questions. That may not seem too difficult, but for some, it's going to take practice and practice in order to be able to accomplish all these problems within that time frame. So the first slide, we're talking about converting kilograms to pounds. And if you look on your cheat sheet, you'll see that there's a little box there that is labeled kilograms to pounds. We're going to convert kilograms to pounds by multiplying by 2.2, and that will give us an answer in pounds. There are a lot of weights, especially the pediatric population, that is recorded in kilograms. And sometimes we have parents that ask, well, the weight is in kilograms, how much does that mean in pounds? A little hint here is that whenever you work these problems out, keep in mind that kilograms, the number to kilograms is always going to be smaller compared to your answer that you're going to get in pounds. So for example, if your patient weighed 20 kilograms and you wanted to convert that into pounds, you would take 20 kilograms, you would multiply that by 2.2, and you should be coming out with the answer of 44 pounds. Kilograms look small compared to your answer in pounds. Let's look at the next slide, where we're taking the weight of pounds and we're converting it to kilograms. When we do this, we're doing the opposite. We're taking the pounds and we're dividing it by 2.2, and that's giving our answer in kilograms. So for example, if you had 44 pounds, you would divide, this is what the slash represents as division, 2.2, and you would come out with 20 kilograms. Again, your 20 kilograms is smaller than 44 pounds, so that's how you can confirm that your answer is right. The next slide. We're talking about tablet calculations. This is about oral medications. This could be a tablet or this could be a capsule that we're wanting to give a patient. When the physician orders a drug to be given, there is a milligram dose that is also included. So, for example, if the doctor had ordered 100 milligrams, that represents drug ordered. And if I go to my cart and I pull out some medication and I find that I have 50 milligram tablets, the drug on hand, In order to know how many tablets I would give the patient, I would take the 100 milligrams and I would set it up in this type of formula, the D over H. D represents the drug ordered, H represents the drug on hand. I would divide it by 50, and then that's going to provide me my answer. And my answer is going to be 2. So I would end up giving 2 tablets of 50 milligrams each to equal to 100 milligrams, which is what's ordered. So this formula is known as D over H equals A. The formula right below it is the exact same thing, it's just written a little bit differently. The drug wanted, we want to give 100 milligrams. The drug wanted is represented by W. The drug on hand is represented by H. It's 50 milligrams. So again, we take 100 milligrams, we divide it by 50. Our answer is 2. So it could be 2 tablets, it could be 2 capsules, whatever form of oral medicine that we have. And this formula is written W over H equals A. Let's take a look at this bottle. Hydromorphone, 500 milligrams, 50 milliliters. So what it is saying is that there are 500 milligrams in this bottle of 50 milliliters. You can't see it very well, but over here on the side, it says 10 milligrams for every 1 milliliter. So every 1 milliliter equals 10 milligrams. There's a total of 50 milliliters in this bottle. Or if you just looked at the entire bottle, it's 500 milligrams for all of the 50 milliliters. So let's say that we need to give a liquid medication. The drug ordered is going to be divided by the drug that we have on hand. Then it will be multiplied by the volume. The volume is going to be the milliliters. We're going to work with this because it's going to start the problem with smaller numbers, and we're going to end with the same answer as if we had even used this formula. So let's just say that the physician had ordered 50 milligrams. That's what's ordered. What I have on hand is this right here, 10 milligrams. And then the volume in milliliters is going to be this. When there's not a number written in front of the milliliters, it automatically defaults to 1. If there's a number in front of the milliliters, then we use that number. But in this case, what we're looking at here, it doesn't have a number. So we're going to put 1 right here. So we're going to take the 50 milligrams, we're going to divide it by 10, and we come up with 5. 5 times 1 equals 5 milliliters. So the formula is D over H times ml equals A. So if the physician wanted us to give 50 milligrams of this hydromorphone, then we would give 5 milliliters, and that would equal 50 milligrams. So right below is the same formula that we previously talked about, the W over H times milliliters equals A, or if you were using tablets, the W over H equals A for tablets. Sometimes there are several concepts that we need to apply for a scenario. A patient may have a weight that is recorded in pounds, and we need to convert it to kilograms. And then a medication sometimes is ordered to be given to the patient based on their weight. So we may have a scenario that tells us that the patient weighs 44 pounds. And so we'll convert that to kilograms and we'll come up with 20 kilograms. And then the physician may say that the patient's to have 10 milligrams per kilogram. So here, the second step, multiply the kilogram to the milligram. So if I have 20 kilograms, I'm actually going to multiply that by 10. So I'll give you a second to do that. You have 10 multiplied by 20. You should come up with 200. So it's 200 milligrams per kilogram. So every kilogram that the patient weighs, according to our calculation, they should receive 200 milligrams. This represents a 24-hour period, one day. The patient should not exceed more than 200 milligrams a day because they only weigh 44 pounds or 20 kilograms. Now that we know the patient's max dose is 200 milligrams, what they want us to do is to use the W over H times V, or the D over H. We should probably take out that Q and just say that it's equals A. So this right here would be your D. Whatever you have on hand equals your A. If you were doing tablets, or if you were doing liquid, your 200 milligrams is what's ordered, what you have on hand, times the milliliters gives you the answer, which is exactly the formula here and the formula here. This is if there's only tablets. Convert Celsius to Fahrenheit. There are several different formulas to use to convert Celsius to Fahrenheit. So if you look on the internet, you might find a different formula than the one that's being used. It doesn't matter what you use as long as you come out with the right answer. So you would take and multiply the temperature by 1.8, then you would add 32. So here's an example. You have Celsius, that would be your temperature. You would multiply that by 1.8. It would yield you an answer. You would then add 32, and then your answer that you get would be in Fahrenheit. Keep in mind that your Celsius temperature is always going to be a small number compared to your Fahrenheit. So if you work this out and the number doesn't come out to be looking larger than the Celsius, then you haven't worked it out properly. Let's convert the Fahrenheit to Celsius. First, you would take the Fahrenheit temperature, and then you would subtract 32. It would yield you an answer. Then you would divide by 1.8, and then that answer would give you the Celsius answer, keeping in mind that your Fahrenheit number is going to be smaller than your Celsius. So when I think about this, converting Fahrenheit to Celsius, I keep in my mind that Fahrenheit is a large number, and I need to break it down. In order to break it down, I first have to subtract. Then I need to conquer and divide. That represents division of 1.8, and then it gives me my Celsius answer. We use the metric system in various ways. First of all, you have to understand, memorize, that 1 kilogram equals 1,000 grams. That 1 gram equals 1,000 milligrams. That 1 milligram equals 1,000 micrograms. 1,000 micrograms equals 1 milligram. 1 liter equals 1,000 milliliters. 1 grain equals 65 milligrams. Let me just kind of work on this one here. Roman numeral 5. Roman numeral 10. If I had 5 grains, I would take 5 and multiply it by 65. And that would give me an answer. Of 325 milligrams. If I had 10 grains, I would take 65 and I would multiply it by 10, and that would give me 650 milligrams. We're going to work on converting larger to smaller and smaller to larger. For example, this 1 gram is larger than milligrams. Therefore, the general rule is taking 1,000 and multiplying it by 1, and you come up with that 1,000 milligrams. This 1 milligram is larger than micrograms, so it's the same rule. You're converting large to smaller, and you're multiplying by 1,000, and that's how you get the 1,000 micrograms. Here, we're converting small to large. So you're taking the 1,000 micrograms, you're dividing it by 1,000, and you're coming up with 1 milligram. 1 liter, we're taking 1 liter and we're converting it to milliliters. So 1 liter is larger than milliliters. Multiplying it by 1,000, you come up with 1,000 milliliters. And it's the same thing with the kilogram up here that I kind of skipped over. You're taking the 1 kilogram, you're multiplying it by 1,000, you're coming up with 1,000 grams. Because 1 kilogram is larger than grams. We measure things in milliliters, and that's a volume, like liter. We measure things in mass, weight, it's grams. We measure things in meters, centimeters, that's your length. And then we measure time, and we measure time in seconds. We also measure it in minutes and in hours. Here's conversions of household measurements compared to metric. This is definitely something that you have to memorize forward and backwards, and you need to be able to recall it quickly. 1 teaspoon equals 5 milliliters, or 5 cc's. Means the same thing. 1 tablespoon equals 15 milliliters, or cc's. 1 ounce equals 30 milliliters. If I had 0.5 ounces, that would equal 15 milliliters. 1 juice glass equals 4 ounces. 4 ounces equals 120 milliliters. I know that because I took 30 milliliters for every ounce, multiplied it by 4, and I came up with 120 milliliters. 1 cup equals 8 ounces. That's 240 milliliters. 1 teacup equals 6 ounces. It's 180 milliliters. So you have to be able to break this down quickly. Proportions. So penicillin may be ordered by weight in milligrams. Penicillin is the name of a medication, or by potency in units. A doctor's order for 160,000 units of penicillin G potassium for Mrs. Henderson is equivalent to 100 milligrams, meaning per 100 milligrams. Select the correct conversion in units for each of the following orders for penicillin G. So, we're looking at 200 milligrams. So 200 milligrams is twice as much as 100 milligrams. So it would be 160 times 2, which yields 320,000 units. So that's the same thing as saying 320, 123. It's the same as 200 milligrams. The next one is 275. 275 milligrams. is what's ordered. What I have on hand is 100 milligrams. This gives me an answer of 2.75. 2.75 is then multiplied by 160,000. That ends up yielding 440,000 units per 275 milligrams. When we write our answers, and we're looking to write them in micrograms, milligrams, grams, we have to be very careful. If we write 0.2 micrograms, this little decimal point may be misunderstood. We need to make sure, and it may be misunderstood as not even really existing, but being a speck on the paper. And this end up looking like 2 micrograms. We definitely know that there's a difference in medication doses between 0.2 and 2 micrograms. So if you have a problem that ends up being 0.2, make sure you put the 0 in front of that dose so that we can understand that it's not 2 mics, that it's 0.2. Sometimes we come up with answers like this one, 1.0. We do not want to have a trailing 0. So we drop off that 0 and write it exactly as it is in a whole number, which is 1 milligram. If we wrote it 1.0 milligrams, it may be misunderstood as 10 milligrams because sometimes that decimal point looks like a speck on paper. It can even be misinterpreted in the EHR, written the same way. So we don't want to lead with any zeros and we don't want to trail with any zeros. If we needed to record an intake on a patient, here you can see on this slide that we have IV intravenous fluids, that's what IVF stands for, infusing at a rate of 125 milliliters an hour for 8 hours. 4 ounces of custard, 1 teacup, 1 glass, 2 tablespoons of soup, and 1 bite of salad. Well, first of all, I have 125 milliliters. I accidentally put gram there, but that's not what I want. It's 125 milliliters that is running every hour for 8 hours. So I would take 125 milliliters and multiply it by 8. That would give me an answer of 1,000 milliliters. 4 ounces of custard. Custard will liquefy at room temperature, so I can count this as liquid. So I would take the 4 ounces and I would multiply it by 30 milliliters, and I would come up with 120 milliliters. I have 1 teacup. 1 teacup is equal to 6 ounces. 6 ounces times 30 milliliters gives me 180 milliliters. Then I have 1 glass, 8 ounces, times 30 milliliters. Gives me 240 milliliters. 2 tablespoons of soup. I know that 1 tablespoon equals 15 milliliters. So 2 tablespoons would give me 30 milliliters. And 1 bite of salad is not liquid at all. Then I would take all of these milliliters and add them up. So I have 1,000 milliliters. I have, I have 120 because I want to make sure that I put those in line. Oh, to rewrite it. All right, 1,000 milliliters, 120 milliliters, 180 milliliters, 240 milliliters, and 30 milliliters. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5. So it looks like I have a total of 1,570 milliliters of intake recorded for the patient. I wanted to make sure that you recognize that there is an abbreviation, Pharmacology 1 abbreviation handout that was provided. And there is also an abbreviation assignment that came from PVC that is reduplicated and handed out to you. There is vocabulary that is associated with Chapter 4. So all of the vocabulary terminology that is in front of Chapter 4, you need to know the definition to. On day 2, I do a show and tell of all of the vocabulary so that you can associate. Don't forget, Roman numerals 1, 5, and 10 are represented by these letters. Here is a medication administration record, also referred to as a MAR. If the patient had a paper MAR, this is exactly how it would look like. And the reason why I'm bringing this to your attention is we do have some facilities that still do paper MAR recording. More and more of our facilities are moving towards the EHR. So I want to teach you a paper MAR in case you're ever faced with that, because sometimes power goes down and they print us out MARs, and students that have never been introduced to a paper MAR don't even know how to use it. So you could be very valuable and very versatile if you know how to use both type of systems. So here, for example, you would have this med administration, and this patient is going to be James Bond. His DOB would be right there. If he had any allergies, this would also be listed on the MAR. And usually the month and the year that we're working with will also be recorded on the MAR. And then we have over here on the left-hand column medications that are listed for the patient. And then we have times scheduled for those medications, 0800, 1700. Make sure that you're familiar with military time because a lot of these meds will be written in military time and sometimes they're just written in normal times. This entire med administration represents a calendar. As you can see here, there's days 1 through 31. So on the month that there are only 28 days, that's all we would do is record up to the 28th day, and we would leave the remainder of the boxes empty. If there are 31 days, then we would record all 31 days. So for example, let's just say that today is the first of the month. If I gave the medication at 8 o'clock in the morning, I would just put my first and last name initial there. In order for someone to understand who SE is, I would also provide my name down here along with my title and then my initials, so that if there was ever a question about the medication being given or not, they could look and reference who it is, initialed that box. So it doesn't matter. If today was the 12th, you would document that med administration on the 12th. If for some reason your patient would refuse, you would circle after you initial, and then on the back of the MAR, you would put an explanation. An example of a drug label indicates that you should mix 9 milliliters of sterile water with 50 milligrams of powder. 500 milligrams of powder, which makes a total of 10 milliliters. To calculate the dose after reconstituting, use the ratio 500 milligrams per 10 milliliter. So this is about reconstitution. We get medication that we have to reconstitute, meaning that it comes in a bottle like this, and it's powder. And there's a small amount of powder at the bottom only. And that it requires, when we read the instructions, that we add 9 milliliters of sterile water. So this powder takes up space. And then when we add 9 milliliters of sterile water, the bottle then has a total of 10 milliliters in it. And it will say that on the instructions, but this bottle is going to be labeled that way. So when we originally picked this up, it just had a little bit of powder at the bottom of it. After we added the 9 milliliters of fluid, it now contains a total of 10 milliliters of fluid. So what happens is this now is 500 milligrams per 10 milliliters. If you had a dose that was ordered of 300 milligrams, and what you had available is 500 milligrams, and the volume or the quantity is 10 milliliters, this is how you would set up the problem. 300 milligrams is the drug that's ordered. 500 milligrams is what you have on hand, so we would take the 300, divide it by 500, and then we would multiply it by 10, and we would come up with the answer of 6. Because after the 300 is divided by 500, it's really 0.6. And then when we multiply that by 10, it gives us the 6 milliliters. So we would draw up 6 milliliters out of this bottle in order to give a 300 milligram dose. The rest of this PowerPoint is some practice problems. So we're going to work on practicing these concepts that we just went over onto these practice problems. This right here is a handout or a chart that comes with this bottle of medication. As you can see on the front of this bottle, this is cefepime, and this bottle contains 1 gram of medication, but it's powder. This chart reads across and down. So let's just look at the first one, this first box up here. A single dose vial for intravenous, intramuscular administration. So this drug here in the bottle can be administered either by IV or IM. The next box says the amount of diluent to be added in milliliters, which means if we needed to reconstitute this, down below are the milliliters that it's telling us to add to the bottle. The next box says the approximate available volume. So what that means is after we add the milliliters, this is how much fluid will be in the bottle. The next box, the appropriate cefepime concentration, milligram to milliliter. And then you can see these numbers below. So let's read over here. 1 gram IV. We would add 10 milliliters of fluid. When we add 10 milliliters of fluid, we'll end up with 11.3 milliliters of fluid in that bottle. The manufacturer says that 100 milligrams per milliliter. So if I had a drug problem that I needed to set up to calculate, I would end up using this if I needed to give it by IV. Let's look at the next one. 1 gram IM. The amount of diluent that we would add would be 2.4 milliliters. After we add the diluent, it says that we'll have 3.6 milliliters in the bottle. But over here, the last box says that there will be 280 milligrams per milliliter. So this is what I would use to set up my problem. The next one talks about 2 grams IV. This right here is 1 gram. So this really doesn't apply. Now the questions are, how much diluent do you add to get cefepime 1 gram IM? So if I go back up here to this 1 gram IM, it tells me that I would end up adding 2.4 milliliters diluent. How many milligrams will be in each milliliter after adding diluent? Well, remember, we went over here, we looked at this, and at the end it said, oh, there is 280 milligrams per milliliter. You're going to have some charts, and you're going to have some drug dosage calculation scenarios, and it's going to require that you look at the chart and read the chart. Let's shade in the hypodermic syringes for an IM injection. We use 3 milliliter syringes to give IM injections. So the first one wants us to shade in 1.5 milliliters. So if I look on this syringe, I can identify that my 1.5 would be right here. So everything here below this line would be shaded in with fluid. I would draw up all of this fluid. Let's look at the next one. 3 milliliters. Well, that's the very top line. So I would fill up fluid in this entire syringe. Let's look at the next one. 2.25. Here's 2, and here's 2.5. So every line here would represent 0.25, because you have 1, 2, 3, 4 of those lines. And then you have 2.5 there. I'm sorry, yes, 2.5. So if I was going to draw this up, this right here, I would draw up all the fluid up until that line. So always look at your syringe so that you can understand how it's calibrated. Not every syringe is calibrated exactly the same, but there are some standard calibrations for example, 3cc syringes. They're all calibrated the same. But another type of syringe will be calibrated slightly different. Here is heparin. 5,000 units per milliliter. So what that is saying is that 5,000 units per 1 milliliter. This right here is what we're going to understand that the doctor ordered. Heparin 2,500 or 2,500 units sub-Q. So we're going to use this formula. So we have 5,000. My bad. Show you the right way here. We have 2,500 is the order, and what we have on hand is 5,000 times 1 milliliter. The answer is going to be 0.5. So in order to give 0.5 milliliters, this right here, the syringe that you're seeing, is different than the syringe that we saw on the previous slide. This syringe is called a TB syringe. It's true that it's used to give tuberculin testing, but it's also used to give subcutaneous heparin. So if you look at this syringe up here at the top, this is a little bit of a closer look. This right here is the plunger of the syringe. If we needed to give 0.5, as you can see right here, is that 0.5. So we would draw everything up until that point in this syringe. This entire syringe holds 1 milliliter of fluid. We're giving 0.5 milliliters of fluid, which is half of that syringe. And here's your answer. Acupril, 20 milligrams PO daily. This is what we're understanding as the physician's order. So I'm going to give you a second here or so to kind of set up that problem. This is the drug that's ordered, the 20 milligrams. This is the drug that we have on hand. You should have used the formula that was D over H. So 20 milligrams is the drug that's ordered. 5 milligrams is the drug that we have on hand. So we're taking the 20 milligrams, dividing it by 5. We're coming up with the answer of 4 tablets. So you would give 4 tablets. Each of them are 5 milligrams. And that's going to equal that dose of 20 milligrams. Here's a memory jogger. Steps to solving some drug dosage calculations. First, change doses to the same unit of measurement if they are different. Set up your equation to work step by step from what dose is ordered, which is also represented by want, and what dose you have on hand, which is represented by have, toward the amount of the available formulation to give the patient. Step 3, calculate the dose using fractions or ratios and proportions. Step number 4, if preferred, use dimensional analysis to solve the problem. Number 5, check your answer for correctness. Ask yourself, does this make sense, knowing the dosage range for the drug? In Farm 2, you're going to begin to learn the dosages of certain medications and what we consider a average dose, low dose, high dose, or extremely high dose, which should not ever exist. Here's a problem for you. We have calcitriol 0.002 milligrams, PO now times 1 dose. That's the order. Now, what we have on hand is the calcitriol capsules, 0.5 micrograms. So milligrams does not match the micrograms. Milligrams are bigger than micrograms. So remember that when we are going big to small, we are multiplying. So we're taking that 0.002 milligrams and we're converting it to micrograms. And the way that we do that is we multiply by 1,000. And then it gives us 2 micrograms. And then we're using the D over H. So the drug ordered is the 2 micrograms, and what we have on hand is a 0.5. So like I said, first we'll convert the 0.002 milligrams by multiplying it by 1,000. We're coming out with 2 mics. And then we're using the D over H equals the answer. So the 2 mics divided by 0.5 mics gives 4 tablets. So we're going to have to give 4 tablets of the 0.5 mics in order to equal 2 mics. The doctor has ordered amoxicillin 1 gram PO stat times 1 dose. But what we have on hand is milligrams. So here we have 1 gram that needs to be converted to milligrams. So 1 gram, this is big, gets multiplied by 1,000, and that gives us 1,000 milligrams. Or you can memorize that 1 gram is equal to 1,000 milligrams. We have the formula, D over H equals A. 1,000 milligrams, that's what the doctor has ordered. What's on hand is 125 milligrams multiplied by 5 milliliters, because that's what it says. It's 125 milligrams per 5 milliliter. That gives us a total of 40 milliliters. So think about it like this: when you're giving medications or when you're working out these drug dosage calculations, does it make sense? Can you imagine what 40 milliliters in a medicine cup looks like? One medicine cup holds 30 milliliters. So you would have to pour an additional 10 milliliters into a second medicine cup. So if you're coming to your patient with 2 medicine cups and they need to take this, that's kind of a big dose. Can we agree? If your answer would come out to be 90 milliliters and it's oral medicine that you need to give to a patient, then that should be a red flag to you that that is way too much medicine to give to one patient at one time. And therefore, if you had an answer of 90 milliliters, that should make sense that this problem isn't working out right. You may need to rework the problem. So every time you come up with an answer, try to visualize what that looks like as an answer. Here's an electronic medical record. It's showing a patient, the age, the gender, the date of birth, a medical record, allergies, the room number, the physician, and the date. The discharge is happening today. The patient will go home taking 125 milligrams of ceftonir oral suspension, PO, BID, which means twice a day. So, if you had to give instructions to the family going home, how many milliliters or teaspoons or tablespoons would the patient need to take every day? Or with each dose? So using the D over H, 125 milligrams is what's on hand. I'm sorry, the 125 milligrams is what's ordered. What is on hand is 250 milligrams. So we're taking the 125, dividing it by 250. And remember here, the 250 milligrams per 5 milliliters. We're going to multiply that by 5 milliliters, and then we come up with 2.5 milliliters BID. So every problem that you work out identifies the dose, one dose. So this patient is getting this medicine at 8 a.m. and 8 p.m. That's twice a day, right? So they're getting a dose of 2.5 milliliters here. And then at 8 p.m., they're getting another dose of 2.5 milliliters. So really, for the entire day, they're getting a total of 5 milliliters for the whole day. But for each dose, they're getting 2.5 milliliters. So some of your questions are going to ask you for a day, or they might ask you for the week. Maybe the patient's going to go on vacation. So how many tablets or how much liquid do they need to have for the entire week? Here we have Saften for oral suspension, 125 milligrams per 5 milliliter. What is ordered is that patient is to receive 350 milligrams of the Saften, PO daily, for 10 days. What formula would you use to set up this problem? You should have said D over H times V equals A. So 350 milligrams is what's ordered. 125 milligrams is what we have on hand, times 5 milliliters, equals 2.8 milliliters. (350 milligrams PO daily times 10 days. You would give a dose of 2.8 milliliters with each dose. I'm not sure why that's there, so just void that out. Here's another one, Rubinol, 0.5 milligrams IM now, and what you have on hand is 0.2 milligrams per milliliter. So how would you set up this problem? You should have said D over H times V equals A. So 0.5 milligrams is what's ordered. What we have on hand is 0.2 milligrams. We're dividing the 0.5 by 0.2, and then we're multiplying by 1 milliliter, and our answer is 2.5 milliliters. So the patient will receive 2.5 milliliters of this medication in order to give the 0.5 milligrams. Heparin, 7,000 international units subcutaneously BID. How much do you give each dose? So if we pull this bottle out of our med cart and the bottle says heparin 5,000 international units per milliliter, and there's only 1 milliliter in the bottle, how much do we give the patient? It's obvious that you would probably need more than one bottle. D over H times V gives us an answer. So 7,000 international units is what's ordered. 5,000 international units is what we have on hand. After you divide that, you would multiply it by 1 milliliter because that's exactly what's in the bottle. And we're using 5,000 per 1 milliliter as what we have on hand. Our answer would be 1.4 milliliters. So in this bottle, it's 1 milliliter. We'd have to get a second bottle and take 0.4 milliliters out of that second bottle. That would give us that 7,000 international units. Triazolam, 1 milligram PO now times 1 dose. What we have on hand is 0.25 milligrams. So what is the formula that you would use? The D over H equals A. 1 milligram is what's ordered. 0.25 milligrams is what we have on hand. Here I have multiply times 1. The previous book had always recognized that a tablet or a capsule represented 1. And so this is an oral medication of tablets. You would multiply by 1. That number would always be 1. And it equals 4 tablets. If you don't use the multiplier times 1, the problem still comes out the exact same answer. This current book that you have just has us skipping that step, which is fine. So we would give 4 tablets of the 0.25 milligrams to equal 1 milligram dose. Hydromorphone, 2 milligrams per 1 milliliter. The order says hydromorphone, 2.5 milligrams IM stat. How many milliliters do you drop in the syringe? So this is for subcutaneous or intramuscular injection. It is also for slow IV use. However, LPNs, that is not your scope of practice. So you can only administer this medication subcutaneous or IM. So how would you set up your problem to get your answer of how many milliliters you would need to drop into a syringe? The D over H times V equals A. So 2.5 milligrams divided by 2 milligrams is what we have on hand, times 1 milliliter. Our answer is 1.25 milliliters we would drop into a syringe in order to administer this subcutaneous or IM. Give Cinnamon 50 milligrams / 500 milligrams PO/QID. Anytime that you see this, it means that there's, in cinnamon, there's carbidopa, levodopa. These are 2 different products combined into 1 tablet. So there's 25 milligrams of the carbidopa, and there's 250 milligrams of the levodopa in 1 tablet. So if you need to give 50 milligrams, and we're just going to kind of ignore that right now, and then you're going to ignore this 250 right now, and we're just going to use this. Set your problem up, D over H, to come up with your answer. Even if you use the entire problem, 50 milligrams / 500 milligrams is what's ordered. What you have on hand is 25 milligrams / 250. you would divide all of these numbers and you still would come out with 2. Even though there's 2 and 2, when you divide, you're only going to use one of these, and that represents 2 tablets. So that's the reason why I had recommended that you cross this out so that it doesn't confuse you, and you just work with this. We had worked out this problem or scenario earlier. It's given to you again, just to see if you can recall how to work it out. Again, what this is really saying is that you have 160,000 units of penicillin per 100 milligrams. So if you have 200 milligrams, it's multiplying that by 2, and you're coming up with the 320,200 milligrams. Now you have the 275. So if you have 275 milligrams, and what you have on hand is 100 milligrams, then you're going to divide the 275 by 100. You come up with 2.75. So 160,000 times 2.75 gives that 440,000 international units. So it's this one and it's this one. This is just the written way of how to figure that out. You're going to have some more of these type of problems in your pre-exam. And of course, if you were in class, if you have any questions, please let me know. I hope this helps.